This is Building Apps with Esri Leaflet. My name's John Gravois. All the slides, all the links, all the demos, it's all online. So if you want to follow along right now, you're welcome to. Or if you want to, dig in deeper, take a look at this stuff when you get back to the office, you're welcome to do that too. I got lucky with a bit.ly link that doesn't have any L's or ones or I's that you can't tell the difference between. So I'll call that a good omen. So we got a half hour, and we're going to talk about some of the fundamentals of Esri Leaflet and some of the fundamentals of Leaflet itself. We'll take a little cruise and check out some of the features and functionality that you can take advantage of. I got a couple demos to show you, and then at the end I'll talk about kind of current events, what's been happening recently, and what you can expect going forward. So hopefully that sounds good. How many of you, before we get started, how many of you already are using Esri Leaflet? Handful? Okay, cool. This will be perfect for the rest of you then. So before we get started, they make me start all my presentations with a disclaimer. I don't know, maybe it's just me. Esri Leaflet is not a product that Esri's selling. It's an open source thing. It's for developers. It's on GitHub, and it's community support. That means that there are Esri folks that are making contributions and working on it, but there's also a lot of contributions that are coming in from customers. Something that we're really proud of, but it makes it a little different than other products that you're used to that have a roadmap and a service level agreement and like a product life cycle where you know that in 2023 we're going to sunset or we're going to make sure to promise to support a browser there. This is more of a organic kind of you get what you pay for kind of thing, and it doesn't cost anything. But I've been working on it for a few years, and it's very near and dear to my heart, so hopefully you'll find it useful too. Before we can really make any sense of what Esri Leaflet is, we have to talk about what Leaflet is. And Leaflet is, I think it's safe to say, the most popular JavaScript library out there. It's mature. It's at this point, it's been out for a few years, so it has a head start on some of the younger ones. But it's used by lots of different organizations, and it's used on websites that generate a lot of traffic. When you go to Craigslist.org or you go to Washington Post, you go to a lot of these websites, they're all using Leaflet. And it's partially because it's good, and it's partially because it's just simple and free, and you can spin it up, without restrictions. So the thing that, one of the reasons people like Leaflet is because it's not very big, so it works really well, especially on a mobile device. If you have a website with a map on a mobile device, it's going to usually work pretty good. And it's a very stable API. It hasn't changed much, so once you learn it, you don't have to go back and relearn it, a year or two later. And just by virtue of being popular, that makes it kind of more popular going forward, because you can go on Stack Overflow or you can start Googling and asking a question and see an answer because somebody else was already using it. So there's a bit of a force multiplier, or I don't know what you'd call it, that helps Leaflet. The simplest code example we could come up with to just talk about how you make a map with Leaflet is, you can create a map and call a method on the map right away. This is called method chaining. So here we have like the object constructor, and then immediately we call set view, which is nice and compact, and developers like that because they can kind of squash everything. If you haven't written a lot of JavaScript, it's a little more opaque. So the same thing, if this one liner down here becomes two lines, you can make your map and declare a variable and use that variable to refer to the object and call a method next. And when you don't chain method calls, you get more readable code. And when you do chain method calls, you just get shorter code, or it looks like less code because there's less lines. So there's no right or wrong reason. I show chaining because it's popular. You'll see it in a lot of Leaflet samples, but it's not anything you have to do. The only other thing that I think is worth noting or paying particular attention to in this example is this is latitude and this is longitude, right? But 45, that if on a Cartesian coordinate system is in y-x order, right? I think all the geographers in the crowd know that everybody's always mixing up lat long and xy. So, there's no wrong or right answer here, but Leaflet was originally developed by a person who was not a geographer. So they heard, lat long seemed more accessible than yx. So that's the way Leaflet's designed. Is, you know, it's in general they think of it as not being for geographers. Doesn't mean geographers can't use it or enjoy it or like it. It's just it was sort of designed with a different crowd in mind. These sort of web developers who are afraid of map projections and don't know anything about, you know, GIS data layers or any of that. So what I mentioned before, something else that sort of makes Leaflet popular is just how small it is. And just like bicyclists get a little too worried about how much their bike weighs, web developers tend to get pretty worried about how much their JavaScript weighs. A Leaflet weighs 36 kilobytes, which is, you know, really small. 1,000 kilobytes is a megabyte. 36 kilobytes is about the same as one map tile. So when you fetch your first map tile, you've already gone above and beyond fetching Leaflet. It's not really an apples to apples comparison, because what the browser does when it loads JavaScript, 36 kilobytes of JavaScript doesn't actually weigh the same amount as 36 KBs of a PNG, but it's still, I think, a good comparison. But Leaflet being small comes at the price of an API that only concerns itself with the bare minimum amount of stuff you could use to make a map and put it on a website. So if you have data, flat files, if you have some GeoJSON, which is kind of the common parlance of the Leaflet world as a data structure, if you want to draw the GeoJSON on the map, you can do that, but you're on your own to go get that data. And I think folks that come from the JS API world or some other APIs, they'll think like, wow, you kind of missed a kind of crucial thing, right? Like, is it an edge case that I want to put some data in a map? No, this is like a really common thing. But it's not that they missed it because they didn't think it was important. The design of Leaflet is such that they think that you should use whatever you want to use. And if you use jQuery, that's great, but Leaflet shouldn't make the decision for you that you need to use jQuery. You could use Fetch if you have a new browser, or you could use something else. A long time ago, somebody said, well, I want to make a wrapper for this and help some people out if they don't know what to use or they don't have something else. So somebody wrote a plugin that's just called Ajax that helps you make a request that happens after the page loads, something that we can fire off and then get a response without blocking the rest of the page from displaying. But having an extra plugin just to load a file, that's, I think, going to be a surprise to some people, but it's okay. That's just the way it is. The good news is, because Leaflet's really popular, there's a big plugin community with a lot of developers who say, Leaflet's great, and I'm doing something, and I don't mind open sourcing my plugin too. So you can find plugins for, I wouldn't say for anything, but for lots and lots and lots of different stuff. Here's the Leaflet website. There's a whole section on plugins. And these aren't the total list of plugins. These are just categories of different plugins. So you can go down here and see plugins for dealing with different data sources and how you overlay the map, or doing something like making the whole page full screen. There's a lot of plugins out there. That's great. There's one caveat, though, that you kind of have to evaluate all these plugins on your own and see whether they're up to date, how to make them work and work with your app. And to see if if they updated when Leaflet made an update, did they refactor the code, or did they just abandon it a couple years ago? You're kind of doing some hunting and pecking or shopping on your own. But I'm not discrediting plugins, because I'm finally coming to the point. Esri Leaflet is a plugin for Leaflet. We're not trying to reinvent the wheel. We're just trying to add something on top of Leaflet that makes it really easy and nice and pleasurable for you to work with the ArcGIS services that you published either to ArcGIS Online or ArcGIS Enterprise. And just like Leaflet doesn't sort of cover everything, Esri Leaflet doesn't cover everything in the ArcGIS ecosystem. We're only dealing with the most popular service types and the types of maps that are the most common that people want to make. So Esri Leaflet's been around a couple years, just like Leaflet. I started working on it, I think, in 2016. But we have at this point well over 50 contributors. Some of those came from Esri, some come from core development or professional services, or they came from a distributor. But there's also lots and lots of people who've contributed to Esri Leaflet that are just like you guys sitting in the crowd. They work for a customer, or a business partner, or somebody else. So I'm pretty proud of that. We also hit a milestone, I think it was like a couple months ago, where we hit 1,000 stars. So this is like the popularity contest on GitHub. It doesn't really mean anything, but it's nice when you hit and it also doesn't really mean anything when you hit like a binary 10 number, but it makes us feel good when we have another 0 at the end, I guess. I don't really worry about this so much as I worry about this. I want the community around Ezra Leaflet to be big, and I want it to be friendly and welcoming, so people that are just getting started don't feel intimidated. There's some open source projects out there that I think are a lot more hostile than they need to be, and that are doing more damage to the community than they're doing good. So that's something that we take really seriously. So if you ever interact with anybody about Ezra Leaflet, you're going to have a positive experience. And the way that we operate, what we're trying to do, this sort of compass or North Star for us, is to try to make sure that whenever we sort of have a default setting, that it makes sense, that it's not going to surprise you, that we're going to follow Leaflet's conventions. So if you've done a lot of Leaflet development, you're not going to think of Ezra Leaflet as being different. It's going to be more similar. And then we're going to keep it simple. So let's take a tour. This, I think, the best way to look at it, to talk about it and deal with it, is by looking at some code. So Leaflet TileLayer, this is not an Ezra Leaflet thing, this is just a Leaflet thing. So if you want to have a slippy map where you can pan and zoom around and the map's getting fetched from a server, it's not getting drawn on the fly, it's just static data. You want it to draw really fast. Raster tiles have been around a long time. You can use ArcGIS Server, ArcGIS Online to cook them, you can use some other stuff. And in Leaflet world, you just have to know where the tiles are. And then you create this TileLayer object, and you can optionally set some attribution so that people kind of know where the tiles came from in the bottom corner, and you add it to the map. You may or may not be surprised by the fact, like here we're creating a new object, but we don't say new l.TileLayer with a capital T. Leaflet's got this convention of what we call factory functions. So you can instantiate a new object without newing it up because there's something in the API that helps. It's not really important that you understand how that works or why. It's just sort of so you'll see the samples and be able to sort of copy and paste them and not worry about it. So that's pretty good. All you have to know is where the tiles are, what the tiling scheme is, and what the attribution is to display. So now I'll show you an Ezra Leaflet class, and this is l.esri.basemaplayer. So here I just say l.esri.basemaplayer streets. And because streets is the world street map, this is an Esri hosted base map. We've got topographic and ocean. We've got all these other well-known base maps. You don't have to know what the URL is. You don't have to know about the attribution. It just works. It's a little bit easier and nicer than that. And so I'll zoom in here, say to somewhere I know that has a custom provider. So I don't know if you can see this is like only medium size, but here as I pan and zoom, the attribution changed. So there's some logic in the API that says, well, Esri's great, but this is not all our data. Customers are contributing data through community maps. There's commercial providers. So when you attribute an Esri base map, it's not just saying Esri, it's saying all the people that worked on the data. That's important to us. So we handle the details. You don't write any code for that. That just is there. The other thing that you get here, we inherit from that tile layer that I showed you before. So properties in the constructor for tile layer that say like minimum zoom 3. So say I zoom out, I'm getting close. This is still not world scale. This is like continent scale. The zoom of the map is disabled because the base map only goes to zoom level 3. That's inherited from Leaflet. So this is us like following the same pattern as Leaflet. So if you look in the documentation for l.esri.basemaplayer, we're going to document all of the basemap strings that are allowed that we know about. But when you go to look at the constructor options, you don't see the minimum zoom. That's because it came from Leaflet. So you have to look at our doc and you have to look at the Leaflet doc if you really want to take advantage of all the options that are available to you. Does that make sense? And the only other thing I'd say is, you can do this without our plugin, but the plugins just kind of adds a nice layer of some icing. It just makes it easier, it makes it work better without you doing more work. That's kind of what APIs are all about, anyway. So I'm gonna go back to some Leaflet fundamentals. GeoJSON, I told you before, that's kind of the parlance of Leaflet, or the the most common data type that you'll see. So if you have GeoJSON on disk in a flat file, or you're writing out and following the GeoJSON spec in your code, you can just define some GeoJSON, and it's like anything else. You've got your geometry and your properties, your attributes, and the shape. You pass the data to l.geojson. This is another class that's in Leaflet itself. And then here you combine pop-up, and here is a feature. You could also have a whole collection of features and dig into those properties. So here the name property, Dinagat Islands, we can wire up a pop-up, so it's not too hard to sort of create some interactivity. You know, a map with dots and a pop-up is kind of the basic of what you do on the web. You can do that pretty easy, and this is digging into that individual GeoJSON feature. So we're building on the fundamentals again. l.esri.FeatureLayer is another class where you point at an Esri feature service that has, you know, hundreds or thousands or hundreds of thousands of features in it, and we draw those on the map. And for the last few years, Esri services support GeoJSON, so you could just ask for GeoJSON. That's great for Leaflet. If you have a really old version of ArcGIS server, Esri Leaflet will turn the Esri JSON that comes back into GeoJSON for you. You don't have to worry about it. So at this point, that's kind of like more telling you how the watch was made than just telling you what time it is. What you need to know as a developer is when you're dealing with your own feature service, you just have to tell us the URL of where it lives. You can optionally set some other parameters, like you could define a layer definition or do some custom styling. But when it comes time to bind a pop-up, you do it the same way. So you get the access to the GeoJSON, and for that feature, you dig into the GeoJSON properties. So that's kind of a nice thing because it works the same way as everywhere else. And another good thing that Ezra Leaflet does for you as we pan around the map, and we zoom around, if we look at the network traffic, let me blow this up so you can actually see something. What we're doing behind the scenes is making some requests to ArcGIS server and saying we want the GeoJSON, but we don't want everything in the database. We just want the features that are within this box, and we divide the map into a bunch of boxes so that we can cache the results. So the good thing about this is it works really well when you have too much data to just draw and display on the map, all like dump out everything. You just can go to the database for a handful of features that you need. TileMapLayer, really similar to the basemap layer, except this is your own map service that you created. You did the cartography, you cooked the map tiles, and you published them. If the tiles exist up on the server and it's cached because the data's not changing, you tell us the URL and you tell us it's a TileMapLayer, and then you draw it. And when you do this, it's super fast because the tiles are just getting, grabbed. If the data is dynamic, either because you want to change the way that the map looks on the fly, or somebody's updating the data in the database like every day, then you can use a dynamic map layer. And this is another map service type you can publish with Pro or ArcGIS Desktop. It has the same URL. This time it doesn't end in a number of a specific layer, but it's the whole map server with however many layers are in the map. But you still get this option if you want to set layer definitions, if you want to filter. Here we're not displaying all the cities, we're just displaying the cities that have a population of like over 100,000 or over 1 million. We'd still do bind pop-up the same way. So here we click on the map and we can ask ArcGIS server, let me look at it, if I could snoop the web traffic so you can see what's going on. Here we call under the hood identify on the map service. So this is using a different operation in ArcGIS server, but you're getting some GeoJSON in Leaflet land, and you can display that pop-up. I don't know if you noticed, it's a little bit, it's not instantaneous because the data's not already there. We drew the image, and then we clicked on the map, and we sent a request to ArcGIS server to say, what's the real feature that's right there, and what attributes does it have? I want the actual JSON. I don't just want a PNG. Still works, it's just like a split-second lag instead. But this is sort of another core class. Image map layer, I don't know how many of you guys in your organization do you publish image services? It's a handful. So an image service is really similar to a dynamic map service in that you're asking for an image. You're asking for it to be drawn for you on the fly and passed back. The thing that differentiates an image service is there's a couple things. you can have multiple bands, like it doesn't have to just be red, green, blue. It could be Landsat data with 8 different bands of like, you know, sub-infrared, or I don't know, I'm not like a remote sensing expert, but you can fetch whatever bands you want. And besides just fetching bands, you can do some math. So a raster function lets you do some math on those bands to display something that's a representation of the imagery that's like actually more perceptible. So here's I think this is a Landsat sample. We're starting with natural color, which is visible 321. But if you do like NDVI, this is like something that's, I think it's for like vegetation health. There it goes. So we asked the image server to say, take that same imagery, but pull out these bands, do some math on them, give me an image on the fly, and then pass it back to me and display that. And that way I can tell what areas have healthy crops or what areas don't. So image services are super powerful. You can also go back and grab a time snapshot. So you can have historical data. One image service can be serving up different time stamps. It could be serving up different like depths. They have image services that give you temperature of the water, and you could ask for it at the surface of the ocean or 30 meters down. So image services are really powerful. You have some options to customize how the image map layer is displayed from Leaflet land. But when you get into raster functions, it's kind of up to you to know what you're asking for and just get it. Like Esri Leaflet doesn't really, just like me, I don't know anything about remote sensing, so I'm just saying, whatever your raster function is, just tell me what it is and we'll pass it along. Something I haven't talked about in talks before that I realized was kind of a big omission in Esri Leaflet. If you look at the doc here on the sidebar, these are all the objects. Layers are really sort of important and common as the base, you know, of how you make a map and add some layers to it. But tasks help us do the actual work. So query tasks, find tasks, these are all sort of documented as well. You can find code snippets and examples. I wanted to do a live interactive demo to talk about kind of what they are and how they work, so we can kind of get a little bit of a feel for it. And query is, I think, probably the most common sort of thing. People want to fetch some data and do something with it. So we're going to focus on query, but the pattern is the same for all the other ones. Identify features, find, those tasks all work the same way. And this may or may not go well, but a long time ago I wrote a blog for the GeoJSON API that compared AMD to what we used to do before AMD. I don't even know what they called that. And I just took one sample and I wrote it the same thing and rewrote the same code in both ways, and people wanted to like compare and contrast. This one uses some like new fancy JavaScript, like some ES6 stuff that you have to have a new browser for, and some old JavaScript that you could run in any old browser from 10 years ago. So if you're seen around, you know, arrow functions or some of these other things, and you're like, I wrote some JavaScript before, but I never saw anything like that. If you want to compare and contrast, you can. So, without further ado, this is, well, I guess I'll tell you when I get to the code. This is query task. This is going to be the new one. So in this sample, this is a demo. You can see the code in the slide deck as well, the links to it. I'm just opening the developer tools so we can actually look at the code at the same time. I'm drawing a feature layer of all of the countries in the world. And then I'm also using a query task to summarize how many of those countries are in the view currently. So you'd see in the top right-hand corner, as I pan around, that number updates. So we're doing a little bit of work on the features, and we're just drawing the features. And there's not a ton of code here. We don't need much map. We need more code than map. So here we've got this map that I told you about before, telling us where we're going to actually set the initial extent, using the gray base map. I've got the URL of the countries, and these are generalized geometries, so they'll draw faster. You can also generalize on the fly. If you got really highly detailed geometry, you can just filter it back. So here I make my feature layer and I add it to the map. And from that feature layer, I can call a query method, and that returns an instance of this task. So we use the task behind the scene to get features to draw, but you can also get a hook into it to use it on your own. So this query task, if you use the GeoJSON API, they have a similar pattern of a task and params. Now I need an event handler. I want to say every time the map moves, once it's done moving, I want to fire an event and actually do some work. And that's when I want to get the count. I don't want to get the count until the map stops moving. And every time the map stops moving, when I call this event map move end, the target for that is the map itself. And if you look in the Leaflet documentation, it tells you what events you can listen for and what you're going to get returned. This map, I can get the bounds of that map at that point. And the bounds are what I'm going to use to do the math. So I'm going to pass those bounds to my function here, get count of visible countries. So in old school JavaScript, we'd say function equals, but here I just say const. So I don't do a var. This is like a variable that's never going to be turned into something else. And now the argument, the parameter that receives is that same map bounds. And now I got my little arrow function, which is a new thing, and curly braces. So at this point, the task that I created at the very start, if I want to do a summary and get some statistics, I need to actually pass the same information. So I say I want, for that feature service with all the counties, tell me the ones that intersect the current map extent. But I don't want all the features. I already got those and drew those. I just want the count. I want ArcGIS Server or ArcGIS Online to tell me the number. I just want a really small answer. And that count I'll use to display. So if I set a breakpoint, let's do this to make it real. I'm clearing the network traffic and I pan the map. We fetch some more tiles and now I'm actually in this function. And if I look here at the callback, there wasn't an error. The count is 27. And the raw response from ArcGIS Server was an object that says count 27. And how that compares, if I go to, there's still, this is the one. Is the text big enough? Yeah, that's not too bad. So here you can see Esri Leaflet helped me construct a query for ArcGIS Online that says where 1 equals 1. I don't want to filter. I want all of the features. But within this bounding box, give me back some JSON, but I only want the count. So then I got the count back. And that just is sort of an example to say that Esri Leaflet is trying to provide a wrapper so that you don't have to kind of know all the idiosyncrasies that the REST API itself expects you to know in order to form good requests. Looking at the doc for Esri Leaflet, if you look under query tasks, you'll see all the options that are available to you. You can call intersects or contains or within, so there's different spatial operators. But there's also stuff like nearby, so you can actually get the features that are like close to the ones that you're looking for. You can set where to filter out and not go for any feature, but only the ones that satisfy like a layer definition. You can also set fields. You can decide whether you want to simplify the geometry. So what I was talking about before, if you don't want that really detailed geometry, you just want a simplified version. This accepts a number between 0 and 1. And under the hood, we do the math to figure out how that affects like the precision that the actual service expects. So all of these methods you can chain together because they're just setting more parameters for you and you just don't worry about the details. But then when you get down to the bottom, running a query or running a count or running bounds, those are asynchronous methods that have a callback because we're going to make a request to the server and have to wait for the response. We don't know how long that's going to take. All right. I think we're good on time, so I'm going to quickly switch back. If you want to look at the old school, I think what we'll have to do, this is the same exact example with older school JavaScript, so I won't spend a bunch of time, but if we go to sources, query task old, this is the same stuff, but here we have like a function, we use var instead of const, we don't have any arrows, so the arguments, it's, you know, if you haven't seen a lot of the new stuff, this might help. I don't know. I just figured that people might be interested in like comparing and contrasting like JavaScript 2019 bleeding edge with stuff that you could do before. That's there as like a little bonus if that's interesting to you. But the logic's exactly the same. So you can compare and contrast two different ways of doing the exact same thing. Sound good? All right. I'm going to kill a couple of these. So the tasks let you chain API parameters together. They make it a little bit more simple and straightforward to actually pass values so you don't have to know the what's behind the scenes. And you can chain them together. And then you get back both a massaged response that Ezra Leaflet's kind of formed in a way that we think you want. And if you want the raw response, you can get that too. I'm gonna save this bit. There's a link if anybody's interested in this that you can get more detail. But somebody asked me on GitHub the other day, they saw all over the place in the Esri Leaflet doc that these methods expose an optional function context. So maybe because we're here, I'll show it briefly, but if this is like something that's new to you, I wouldn't worry about it too much. So here's the same exact, I'll show you the doc first so we can see like how you could try to figure this out on your own. So in bounds, we have a callback argument and then this context. And the context here, it says accepts an optional function context. So we're gonna actually use that, and I'm gonna talk through like what that means. So here we've got the same, almost the same exact demo where we do the query task, we have the feature layer at the same time, but we're going to pass through that context so we can get a reference to a variable within the callback. Because this is kind of a problem in JavaScript that the scope changes out from underneath you, especially when you call an asynchronous function. So here we're gonna get, instead of getting a count, I'm asking for what the bounds is every time I change the map, the bounds of the features. So like a union of all the features that are within the bounds. So if I step down into this breakpoint and I have the same exact function where I passed, last time I just passed the map bounds, this time I'm gonna pass a context as well. So when I call my first function, I pass the map bounds and the map. Then when I call this function, I'm doing the same thing. I'm chaining a couple of method calls together so that I can get the bounds with all the filtering that I wanted. But then when I get down in here, when I call bounds, all the code that I'm highlighting right now is the callback function. It could be named or it can just be an anonymous function, but that you need to pass. This context that I passed afterwards, this is the optional thing. So when I pass through that context, then when I'm inside that method call, I don't know if you guys have ever written JavaScript. I've written plenty of times where I ask what this is, and this is the window. And I don't want it to be the window. I want it to be the class that called the method. So passing that through allows you to get a reference to a class that you wrote, or the map, or some other variable that otherwise wouldn't be accessible. I tried doing all this with the arrow functions and the new like 2019 JavaScript when I wrote this sample, and at first it didn't work, and I was like, why is this not working? And I looked it up and I realized it's because in the language this was such a problem and so annoying for so many people and so hard to understand that arrow functions automatically have what we call a lexical scope. So this will refer to what you expected it to refer to, whether you do the binding or not. So what that means for you, I don't know. It depends on what kind of JavaScript you're writing. It's probably more of like a Easter egg or trouble. I see that I've got to be done. Oh my gosh, I got to be done now. All right. I've never done this in a half hour before. I didn't do it in a half hour this time, but I'm going to quit. If you have questions or you want to talk more, I'm happy to exit the demo theater and talk to you in the back. There's a little bit more, especially the Q&A, but I've got some other links and stuff to share, but you can access it all from home. Thank you very much. No, that's my fault.